Picking back up where we left off with the previous conversation, we were introducing molarity, and now I just want to use molarity as a conversion factor. We're going to take a few minutes to do this, and that's why I wanted to give it a separate video. So molarity is a conversion factor. We've done conversion factors before, right? So if we have molarity as a conversion factor, we can say, oh, well, my equality is, if there's 3.5 molar HCl, there must be 3.5 moles of HCl for 1 liter of solution, right? And so I can write my conversion factors as either 3.5 moles over 1 liter or 1 liter over 3.5 moles. Okay? So we can do the same thing, of course, with conversion factors from any of the other concentrations that we used. We used mass per mass, right? And that way we can say 10 grams over 100 grams or 100 grams over 10 grams, right? We used volume per volume, right? And that would be 12 moles of ethanol over 100 mils of solution or 100 mils of solution, right? These are decent conversion factors, and we can make up our own conversion factors from any of the units that we get because we're always given what those things actually are. 5% in a mass per volume is going to be grams per mils, right? And we can do the same thing for molarity. All right, so let's do a couple learning checks here. Pause the video, have a look at this, and come back and check your work against mine. Okay, so the question is, how many grams of sodium hydroxide are needed? Grams of sodium hydroxide are needed to prepare 75 grams of a 14% mass per mass. So I'm going to set myself up a nice picket fence here. Try to draw a straight line, not doing a very good job. Don't know how many of those I need. How many grams of sodium hydroxide are needed to prepare 75 grams of blank? All right, so I know that 14% mass per mass is 14 grams of sodium hydroxide over 100 grams of solution, right? So I'm going to put my grams of sodium hydroxide here, and I see I'm related to 100 grams of solution, right? So far so good. So I've got my grams of sodium hydroxide, which I need, and I've got to cross this off. So I come back over here and go, oh, aha, 75 grams of the solution. Grams of the solution, right? That'll cross that off. I actually think I'm done. That's it, I'm done, right? So let's put the numbers in. It's 75 grams of solution. So what I needed, and I had 14%. Here's my 14%, right? You see how I just used my definition of percent for my conversion factor? So it looks like the answer is going to be 75 times 14 divided by 100, and I'm done. Wow, that was nice. 75 times 14 divided by 100. How do you spell 100? That 10.5. Bam. Love it. 10.5 grams of sodium hydroxide. Okay, let's do another one. Pause the video and come back and check your answer against this. Okay, I'm going to suppose you paused it. It's grams of aluminum chloride that I want, right? And I'm going to try to draw a straight line here someday. Right, straight line. I don't know how many of those I'm going to need. But, okay, so, and it looks like I need a volume of 125. But this is not in grams, it's in molars, right? So remember, moles is equal to moles per liter. So I'm going to have to get my grams into moles in order to use that number there. That number's not going to be useful to me until I get my grams into moles. So I'm going to do that. I'm going to go grams per mole of my aluminum chloride, right? AlCl3. AlCl3. My grams are here, and that's what I wanted. Now I'm going to have to cross that off, but I can do that because I've got moles per liter. And I was given mils, so I can go liters per mil and mils. Right? So this is 125 mils. There's 1,000 mils in a liter. The moles per liter is 0.150. And my gram, I just need my molar mass of aluminum chloride. So let me come back over here. Molar mass of aluminum chloride, 26.982. 26.982 plus 3 times 35.45, right? Because chloride is 35.45. Right? Enter. 133.332 is my grams per mole, 133.332. And I just multiply all my denominators and divide by my, multiply my numerators and divide by denominators, and I'm done. So it's 125 times 1 times 0.15 times 133.332 divided by 1,000. And I get 2.499. 2.499. Bam. Grams of aluminum chloride is what I need. All right, so hopefully that's helpful. Now we're going to do one last problem, and this one is a little more complicated, and that's why I wanted to have a separate video, because this has got more work to do. It's going to be similar stuff we've done, but let's do it now. Pause the video, make some work at this, and then come back and compare your work to mine. Okay, so I see that I'm going to be asked for liters. So I'm going to come here and I'm going to say liters of solution. Okay, I'll make myself a picket fence. Don't know how many I'm going to need, so let's just do that. Okay, so how many liters of a 0.1? And I know on liters of solution, if I've got my molar, I can say liters of solution per moles, right? That's like 1 over molarity is what that is. Okay, it's the reciprocal of molarity. So I've got liters of solution. That's perfect. Now, I'm looking for grams of zinc. So I'm going to have to go, this is moles of HCl. So I'm going to go moles of HCl. And I know that there are 2 moles of HCl for every 1 mole of zinc, right? So I'll relate that to moles of zinc. Can you read my writing? I was going a little bit fast there. Moles of zinc. And I've got to have moles of zinc here, because those are going to cross off. You see, these will cross off nicely. Liters is what I wanted. Moles of zinc, but aha, I've gotten grams of zinc is what I've got. So I'm going to convert that to grams of zinc like that. Right? Because this is my upside down, this right here is 1 over molecular weight, right? Grams of zinc, or it's atomic weight, I guess, at this point. All right, so my grams of zinc will cross off my moles of zinc will cross off, my grams of zinc will cross off, and I'm left with what I wanted. All right, so let's put the numbers in. I've got 5.32 grams of zinc. The molar mass of zinc is, let's go back over here, zinc is 65.38 grams per mole, right? 65.38 grams per mole. It's 2 moles of HCl for every 1 mole, and I get that from here, for every 1 mole of zinc. And it's, the concentration's 1.5 moles per 1 liter. All right, so let's do that. 5.32 times 2 divided by 65.38 divided by 1.5 is equal to 0.10849 ... liters of solution. And that's what I was asked. How many liters do I need? And that's my answer. All right, so that's a lot of work with calculations, but this is all built on stuff we've done previously. So hopefully it looks familiar. Go get some practice. Good luck.